This is a chain rule, though. Do you see why? I've got two operations, really, basically there. I've got a tangent, obviously. But then what else do I have? I have a 2 times x. So here's the thing. You might want to think, well, that's really, I could say, if I want to put, this one didn't have parentheses, so if I wanted to put parentheses in there, wouldn't I say tangent and then the 2x goes together? So don't I have an inside and outside? What is inside, what's outside here? Tangent's outside, 2x is inside. I do have something more than x on the inside. So this is a chain rule. So I've got to do the derivative of the outside. Derivative of outside would be the derivative of the tangent. Derivative of the tangent is secant squared. Got those memorized yet? And what happens to the inside? Not a thing right here. Okay? Inside, I'm doing the derivative of the outside, so the inside stays the same. Then I multiply that by the derivative of the inside. Well, the inside is just 2x, so the derivative is just 2. And the best way to write that is put the 2 in front and then the secant squared 2x behind. Right, because I guess it is good to review here. Can I multiply the 2 times the 2x, get 4x? Can't do that. Cannot multiply this 2 times the 2x because the 2x is inside the secant. The 2 is not. So it's just 2 times secant squared 2x. All right. That was number 3. Let's do number 4 here. Number 4 is going to be y equals the sine of parentheses x squared. And this is a good one to do after we just did, no, okay, this is the same. All right, never mind. I'll make another point here in just a second. Okay. All right, so here again, what do we got? 2 things, right? We've got the sine, and then we've got x squared. Which is in, which is out. Well, it's very much like the tangent there. Inside is x squared. The out is the sine. Yeah, the outside is the sine. The inside is the x squared. And so the derivative will be derivative of the outside. Derivative of sine is cosine. Inside stays the same. So cosine of x squared is the derivative of the outside. Derivative of the inside is 2x. And again, this 2x is in no way associated with that x squared because the x squared is the argument of the cosine. So probably you would see it more written this way. 2x cosine of x squared. But you see where that all comes from. Is this okay? So far, so good. All right, well, yeah, let's kind of leave that one up so we can see it and compare that to this one. So we have y equals the cosine 5th power of t. And you may or may not have parentheses there. This one is a bit different than the previous one. Here's why. For one thing, if I said the inside was just the t, that's nothing special. That's just t. But that's really not what complicates this, why I have to use a chain rule here. Really, it kind of comes from the interpretation of what it means cosine 5th power of t. What I would recommend is we rewrite this. This is just a nice form, a nice condensed form, but this would better be written as cosine t to the 5th power. Doesn't that mean the same thing? Cosine to 5th power of t means 5 cosine of t's, which that's also what this means, but the advantage of doing it this way is it's much more clear what the inside is and what the outside is. What's the inside and what's the outside here? Actually, on this one, which one's the inside? The cosine. You see here? The outside is the fifth power. Whereas up here, on the previous two, it was sine of x squared. The trig function was on the outside, and the x squared was on the inside. Here it's flip-flopped, isn't it? The cosine's the inside, the fifth power is the outside. And that's significant, right? Because on the chain rule, you do the derivative of the outside, then you do the derivative of the inside. With me? So yeah, if you get one of these fifth power trig functions, whatever power trig, I would rewrite it in more form like this. It's much more clear. All right, so what's the derivative? Well, the derivative by the chain rule says derivative of the outside, which is just the fifth power rule. Just do the power rule there. Bring down the power, leave the inside alone, and then subtract 1 from the power. So it'd be 5 times the cosine of t to the fourth power. Then we're going to do times what? Derivative of the inside. The inside is cosine. What's the derivative of cosine? Negative sine. So it'd be negative sine t for the derivative of the inside. Okay, now clean this up a bit. That is, we say negative, but it means negative 1. So don't I have negative 1 times 5? So don't I have negative 5 here? You can leave it cosine t to the fourth power, but we can now go back to that kind of condensed form, do cosine fourth power t, and then sine t would be the cleanest version of that derivative. See where all that comes from. Question or concern? Is that okay? All right. Say we have y equals cotangent 5 theta plus 4 sine of 4 theta, plus 3a. Just to make another quick point here. You see here, this one's going to be a couple of chain rules. I'm going to have to use a chain rule here, aren't I? Cotangent of 5 theta, doesn't that have a cotangent and then I have a 5 theta? That's a chain rule. And then I'll have to use a chain rule here. Sine of 4 theta, same deal. I've got the sine and then I've got the 4 theta. And we'll talk about the 3a in just a second. All right, so the derivative here is going to be, well, it is plus, though, between these. That's good, because all I have to do is do the derivative of cotangent 5 theta, then do the derivative of sine 4 theta, and then do the derivative. I can just do all those derivatives just separately. All right, let's start with the derivative of cotangent 5 theta. Well, that's a chain rule. What's the inside, what's the outside? Well, if it's in this form, put your parentheses around it if you have to. Cotangent is which part? Inside or outside? It's the outside. The 5 theta is the inside. All right, so what's the derivative? Well, you do the derivative of the outside, derivative of cotangent. What's the derivative of cotangent? Negative cosecant squared. The inside stays the same. Then the derivative of the inside is 5. Because it's just 5 theta. It's just like 5x. So the derivative is just 5. Then I do plus. Since it's plus, I can just do the derivative then of sine 4 theta. Well, that's the same thing. Put your parentheses around 4 theta if you want. Outside is sine. The inside is 4 theta. So that would be, derivative of the outside would be cosine. The inside stays the same. Times the derivative of the inside. The inside is 4 theta, so the derivative is 4. Now, with the variable here being theta, what about a? Going to the last one here. How do I treat a? It's a constant. Yeah. If I'm talking theta is my variable, a is a constant. So this is 3a. That's just a constant. What's the derivative? 0. So cleaning that up, the derivative, ignore my scratching there. Get rid of some of it.
So when you're using theta in there like that,
It's the variable.
Your variable that's not to a power goes on as the constant.
Yes. So clean it up. I would just write that first one as -5 cosecant squared 5 theta. This, again, the 4 is not associated with this cosine 4 theta, so just put it up front. So just 4 cosine 4 theta. And then the 0. Of course, you don't have to write it. With me? All right. Try one more here at least. Y equals 3x minus 4 over square root of 4x minus 7. (3x minus 4 over the square root of 4x minus 7). Okay, well, one thing I can see is I better write that square root as the 1/2 power. So it'll be 3x minus 4 over 4x minus 7 to the 1/2 power. Let's rewrite it that way. Okay. So going to the derivative here, first rule, this is going to be a combination, isn't it, rules? What's the first rule of note here? Well, I've got a quotient, don't I? So I've got to apply the quotient rule. Low d high minus high d low over low squared. So low, 4x minus 7 to the 1/2 times d of the high. Well, d of the high is nice. Derivative of 3x is 3. Derivative of minus 4 is 0, so it's just 3. Minus high, 3x minus 4, times d of the low. Well, that's why we're bringing it up here now, because how am I going to do the derivative of the low? It's chain rule, isn't it? I've got inside is 4x minus 7, outside is the 1/2 power. Yeah, I'm going to have to use the chain rule. Chain rule says do the derivative of the outside, which is the 1/2 power, so bring down that. Leave the inside the same. Subtract 1 from the old power, which would give you minus 1/2. Then multiply by the derivative of the inside, which the derivative of the inside is easy. What's the derivative of the inside? We're talking 4x minus 7, so the derivative is 4. And then I have on the bottom low square. So 4x minus 7 to the 1/2 squared. That's a lovely mess, isn't it? All right, well, clean it up a bit. I don't think there's much I can do here with the 4x minus 7. Let's just say, well, let's do this. Let's say it's 3. I don't know. How are we going to do this? 3 times 4x minus 7 to the 1/2. Now over here on this part, starting here, all this is times, so what about this 1/2 and 4? Don't I cancel there? Leaves me a 2. So here's what I see for that. I got a minus 2 times 3x minus 4 times 4x minus 7 to the negative 1/2. And then the bottom, well, that worked out nicely on the bottom, doesn't it? What is the 1/2 power squared? Doesn't that just make, yeah, that's just 1 because you're multiplying. Those cancel, so you just get 1. So it's 4x minus 7 to the 1 power of 1, so it's just 4x minus 7. We could spend more time cleaning that up, but maybe later. At a later date we may talk more about that. Okay? Because I wanted to show you one more real quickly here. What about g of x equals the third root of 5 minus sine 2x? Third root of all of 5 minus sine 2x. What's the first thing you see? Make that a 1/3 power. Yeah, so 5 minus sine 2x, make that 1/3 power instead of cube root. All right, so obviously one thing we see there is chain rule. Treat this here as the inside, the 1/3 power. That's going to be our outside, so the derivative using that chain rule would be bring down the power. The outside is the power, so power rule. Bring down the power, leave the inside the same, subtract 1 from the old power, which would be negative 2/3. Then I have to do the derivative of the inside. Well, the derivative of 5 is 0. The derivative of minus sine would be, the derivative of sine is cosine, so minus sine would be minus cosine, wouldn't it? But do you see something else that needs to be taking the derivative of? I've not taken the derivative of everything here. I've taken the derivative of this 1/3 power. I've taken the derivative of the sine. What else is missing? I still need to take the derivative of this, don't I? In other words, I've got a chain rule within a chain rule. What else has to be multiplied here? Well, I need to do the derivative of this inside. This is the inside of the inside, so to speak. You see what I'm saying? So this, I still need to multiply by another 2, which is the derivative of 2x. So you just got to continue your chain rule, do the derivative of the outside, then do the derivative of the inside. Then if you have an inside of the inside, you got to do the derivative of the inside, which that's what I've got. Isn't the 2x inside of the inside? See what I'm saying? So the chain rule just says keep doing your derivatives. Clean it up. Let's see. That would be, I got a 1/3, a minus, and a 2. That's minus 2/3. 5 minus sine 2x to the minus 2/3. Could flip that over to the bottom if you wanted to.